Alrighty, friends, we are back at it with 8.4 day 2. Here what we're going to be doing is we are going to learn how do I go ahead and multiply numbers that are in scientific notation. All right, this is going to be a combination of things that we have learned. One of the things you'll need to remember is that when you have a base to a power multiplied by the same base to a power, in that scenario, you add the powers. That's one thing we learned last week that you're going to need to remember. Another thing you're going to need to remember is that when you have a base raised to a power and then raised to another power, that in that scenario, you're going to multiply the powers together. So those two rules that we learned in the past are really going to come into play today. So you're going to want a calculator for this set of notes and then for your homework as well. So let's see. This is going to be one scientific number times another. It looks very complicated. But with multiplication, you can multiply the numbers in any order you want. So I'm going to kind of group them together. I'm going to take my constants and I'm going to take 8.5 and multiply that by 1.7. Then I'm going to multiply 10 to the second times 10 to the sixth. Okay, these two, according to my calculator, I'm going to go 8.5 times 1.7. That part gets me 14.45. When I look at my scientific notation, I'm utilizing this rule right here. I have 10 to a power times 10 to a power. So according to that rule, since I have the same base, I just add the powers. So 2 plus 8. So, 2 plus 6. I added them together already. So I, at this point, have 14.45 times 10 to the 8th. But the problem is right here, this number, 14.45, is not in scientific notation, because 14 is greater than 10. It's more than one digit. So I'm going to now take this part and do what we did yesterday in class. I'm going to go ahead and put that decimal where it belongs for proper scientific notation. But it really is over here, which is 1 to the right. So writing that number in scientific notation, it would look like this. But then I still need to multiply that by this other 10 to the 8th. So now I'm basically done because I have my 1.445 for the constant, and then these two, again utilizing this rule, will become 10 because they share a base to the 1 plus 8 or 9 power. So that is how I write my final product. Let's try it again. Group the numbers together. 1.1 times 4.2. Then group the powers of 10 together. So 10 to the 7 times 10 to the second. Get out your calculator. I'm approaching every problem the same way. 1.1 times 4.2. And these are giving me 4.62. Then I use my powers rule, saying I have base 10 to the 7, base 10 to the second. I'm going to add my powers and end up with 10 to the ninth. And this one is actually good because 4.62 only has a one-digit number to the left. So I don't even need to rewrite this one. And my final answer is going to be that 4.62 times 10 to the ninth. I don't have to make any changes or tweaks like I did in the first example. Okay, let's try it again. Same process every time. Group the constants together, and then we can group the powers of 10 together. We don't care that they're negative. We follow all the same rules. It just means that the decimal place will be moving to the left when we rewrite that in standard form. So I'm going to get out my calculator and I'm going to take 8.1 times 9.3 and I get 75.33. Then that's going to get multiplied by 10. Now I have 10 to the negative 4 and base 10 to the negative 6. So I need to add negative 4 plus negative 6, and that's going to be negative 10. So here I do get a little sad face because I can't have the decimal here. I would need to write it as 7.533 because I can only have one digit to the left, not two. So I think, okay, but it's supposed to be here, which is 1 to the right of where I have it. So the first number becomes 7.533 times 10 to the first once it's written in proper scientific notation. And then it's getting multiplied by that 10 to the negative 10. But this part's pretty easy because these are the same base. Excuse me. So my 7.533 doesn't change. And then my power of 10 is 1 plus negative 10 for these two numbers. And so I end up with a negative 9 as my power. Why don't you turn the video off? Ooh, I know why. The next one's going to be tricky. So there's a couple ways for you to think about the next one. This is to the power of 3. Keep in mind that power of 3 means you are taking what you have and you are multiplying it by itself 3 times. But again, if I wanted to do this in separate parts, I'm basically looking at 5.7 to the third because it's multiplied by itself 3 times, and 10 to the negative 8 to the third because it is multiplied by itself 3 times. So I'm going to use my calculator for the number part. If you have a cube button on your calculator, that's awesome. If you have to, you can take 5.7 times 5.7 times 5.7. Either way, that part becomes 185.193. And then this part right here, let's go back to the very top. This is what we need to use. If we have a base raised to a power with parentheses and then another power, those two powers multiply. So looking at my situation, I'm going to multiply these two powers and get negative 24 as my new power. However, like we've run into so many times, 185 has 3 digits to the left of the decimal, and it can't be that way. I need to put my decimal here. So for my answer to be correct, I'll need 1.85193. Now I just have to figure out what power of 10 that is. So this is where the decimal belongs, and for me to get there, I need to move it over 2 from where I placed it to the right. So that becomes a power of 2. So all I did there was rewrite this number into scientific notation. And now I have to multiply again by that 10 to the negative 24. So final step, 1.85193. And then my powers of 10, I have a 2 here and a negative 24. So 2 plus negative 24 lands me at negative 22 as my final power. All right, last one. Similar process. This one is squared. So that's going to be 1.4 times 10 to the third times 1.4 times 10 to the third. If you want to partner them up, that's going to be 1.4 squared or multiplied by itself, and 10 to the third squared. According to my calculator, I'm going to have 1.4 squared, and I'm going to get 1.96. Here, I multiply the powers to become a 6. And this is awesome. What a great way to end, because I only have one digit to the left. which means I don't have to make any changes, and this is my final answer. So generally speaking, you want to multiply the regular numbers. So you're going to multiply the constants. Then you're going to do the powers of 10, right? So you need to add the powers of 10. But then you might need to rewrite your constant. So you might have to rewrite your constant in scientific notation. And then lastly, you would recombine the powers of 10 again. So that's the process we've been using every single time. I multiplied the constants, I combined my powers of 10. And then if needed, you would have to rewrite. So this step is not always necessary. So these can be a little tricky, so make sure you've watched the video, maybe do a few more examples if you need to before you start your homework. And again, we're going to be looking at an IXL for today. Those are just a real good way for you to practice until you know what you're doing. And in this case, you're going to be an IXL G4. And as always, you're going to go to 80. Anything above that is going to be extra credit. And those are going to be due Thursday at 10 p.m. All right, go be awesome, guys.